I wanted to walk through how to make oscilloscope art like this picture here of my cat, the titular penny Fourier whom we ponder. Here's the original photo. We won't get into the technical parts of how it works. For that, I'd highly recommend checking out this YouTube channel by, I assume, Lennartson, and specifically this playlist. Links will be in the description. This is also not a tutorial on how to make oscilloscope art with music. I wish I could do that, but I'm not musically inclined enough to do so. That's where the image that you're seeing on the scope corresponds exactly to the noise that you hear. Whereas for this image, the noise wouldn't sound anything like music. It is simply created so that you get this particular image on the screen. And so we're going to walk through how to make these more intricate images where it isn't musical sound, because I think that this is a really cool use of the scope and a type of oscilloscope art that I don't see a lot of people doing, and one that I think is relatively easy for anyone to do. And also, if you're interested in doing this and would like information on what oscilloscope to buy, I'm also going to point you again to Lennartson's playlist. He has a great video walking through how to pick the correct scope to buy. I'm not going to touch on that in this video. In order to create images or even videos like that image of Penny on the scope, we're going to use this code video to Lissajous oscilloscope, which can be found publicly available on GitHub. Now, Lissajous is a term for, or at least I think that's how it's pronounced. I assume this guy was French, and I don't know, they have crazy pronunciation, but is an image that can be formed using these two sine waves and some varying phase angle if you want to get it to move. So this kind of image is pretty common to display on an oscilloscope because it's very easy if you have some sort of signal generator to generate sine and cosine waves of varying amplitudes and frequencies and phase shifts. So sort of a cool little thing. We're not going to do it on our oscilloscope today, but it's kind of an intro XY mode oscilloscope thing you might play around with. So I think that's where the name comes from. But basically, they've written some code that will take a vectorized image or images and turn them into a sound file, which we can insert into the oscilloscope, and those varying voltage levels will trace out the image on the screen. Now, this code relies on two other pieces of code that we'll just install and touch on. Potrace, which will take the image that we feed it, or images if they are frames of a video, and turn it into these vectorized versions of that image in order for the Python code to tell the sound file for the XY mode in the oscilloscope to trace out that vector, as well as FFmpeg if we're doing a video to just extract a bunch of still images from the various frames of the video. I hope that this video will be helpful because this code here and the README, I think, are missing a lot of important details that will be covered in this video to help you if you stumble on getting this running, because I think it's really cool when you get it going, and I don't want people to get stuck in the same way that I did. So let's go ahead and start by cloning this Git repo. So, okay, we just have these two Python files, video to oscilloscope raster and video to oscilloscope vector. Now, one thing to note, and they even talk about this in the README, is that the code is a little bit computationally intense, and they recommend using PyPy in order to get the code to run faster. So in order to get PyPy installed here, I'm going to use something called pyenv. It's just sort of a nice way to be able to deal with multiple different Python versions and virtual environments. I'll put a link in the description as well as to this Git repo, and obviously all this stuff, just find it in the description. Very easy to install. I find it very useful. So the first thing I did was just pyenv install, and I installed this version of PyPy. I've already done this, so when I go to do it, it'll say it already exists, so I'm not going to install it, but if it didn't exist, it would just install here. It might take a little bit of time, but it should just run smoothly. And then we want to create a virtual environment from this PyPy install. Penny's walking all over my keyboard. So to do that, we just do pyenv virtual env, and then we give it the Python version we want to base it off of. So this, and then we give it the name of the virtual environment. So I'll just call it Oscilloscope demo. So now it's created that virtual environment, Oscilloscope demo, and then we want to tell it to use that environment locally. Before I do that, I just want to go ahead and show my version of Python. It's just regular Python 3.12. And now if I do pyenv local scope demo, so all that did was create this text file, that .python version that pyenv monitors in directories and sees, okay, use this virtual environment, and then I have it display on my screen here and the command line prompt. But now if we run Python version, we can see that it's running this PyPy version 7.3.15 on top of Python 3.10. So cool, we have PyPy installed. So the next changes we have to make are that this code, I think, was written with Windows in mind. So if we look through some of the code here, we'll see that it assumes that potrace is installed to a .exe file. And so I think it was written with Windows in mind, and there are a couple other things that I don't have a Windows computer, so I couldn't test it on, but if you want to get it working on a Unix-like system, so I've done this on both my MacBook Pro here, which has the M1 chip, so here's the information for the MacBook, and then also on another computer that's running Ubuntu 22.04, I believe. So I've already run this in a different, this is a different install of this Git repo. And you can see I've made a couple changes. So the first is that potrace here, we're going to install this, and it's not going to have the .exe file extension because it won't be on Windows. And then I also upped the sample rate. So there are various settings in these files you can play with. I played with them a little bit. I found that the sample rate improvement helps a good amount. The other ones didn't affect it that much. So like the frames per second, your oscilloscope won't really be able to do too fast. So 15 seemed fine, and the other ones, I don't know, didn't seem to have a huge effect. And then the final thing is that this potrace executable is originally run using subprocess, but I couldn't get it to work on my Mac or Linux with that. So I just did an os.system run. I don't know if it would work if you had a Windows. I mean, even changing this command here, since you're not going to be using that on a Unix-like system. I couldn't get the subprocess to run, so I just changed it to OS system. You already have OS installed, so you might need to make those changes. So I'm just gonna, I'll put those to a patch. I'll just call it like nix updates.patch, and then move this to our new install, and then I'll git apply that patch. So now those changes in the file are here too. So if we just went ahead and tried to run this vid to oscilloscope vec, we'll run into some errors. So SVG isn't installed, so I have figured out that the version, in order to get SVG here working, you have to install svg.path using pip. And then if we go to run it again, we'll run this error with numpy. So we also have to pip install numpy. So ideally, these would come in a requirements.txt, and you would just pip install -r requirements.txt, but they don't seem to have done that in this Git repo. So okay, now it's telling us that these directories don't exist. So now we have to do the rest of the setup that the Python code, maybe I could have made the changes here as well, but we're just going to do it manually to make these directories if they don't exist. So we can see in the README, they tell us that you need to have the structure laid out like this. So we need this input BMPs. So we'll make that folder. We need, I think the raw PNGs and the input PNGs is only needed for the raster version. So we're not going to do that. But if you were doing that, I think you need to run that. I guess if I'm wrong, we'll just make it in the end. So we need the SVG, and then we need Potrace installed. So if we go ahead and open Potrace here, you can see about this other software, how it's going to turn these bitmap images into vector graphics that this Python file will use. I'm sure that there's a lot of interesting information here if you wanted to dive into it. I don't know that much about it. I'm just kind of installing it and running with it. So I've tried this with both Mac and Linux. This is a Mac, so we'll do that version, but presumably it works for Windows as well. So we'll just save the tar file. Extract it. And so now if we look at how this code expects Potrace, it doesn't have the specific version information. So I'll just move this file to just Potrace. Now we can remove the tar file. If we look in Potrace, we can see it has this executable. Now, when you go to execute this on a Mac, it might come up with the security issue stuff. So in order to get that to work, you just need to go into System Settings, go into Privacy and Security. At the bottom here, it will have this. It was blocked because it doesn't know the developers allow anyway. You'll have to put in your password. And then when you go to run it again, just run it with help, it will come up with another error message. We'll just say, go ahead and open it. So it is just a command line executable that you could run on your own, but the Python code will run it for us. So that should now all be set up as well. And you'll also need ffmpeg installed. So I already have it installed. I'm not going to go through it. It takes a little bit, but I just used brew install ffmpeg. And you need Homebrew installed for that. If you don't have that installed, I'll put a link in the description to Homebrew, but you'll need to install that as well. I'm sure there are other ways to get ffmpeg, but that's how I used it. So, okay, we should be all good to go now. So how do we get this running on some video? Well, I guess first I should say if you want to do just a still image, like that image of Penny, all I did was went to input BMPs and I put a couple images, so it'd be more than one frame, although I'm sure you could just do one frame and just name them like 1.bmp, 2.bmp, and so on. And then it just generated a file, that was fractions of a second, and then I just went into Audacity and like copied and pasted it a bunch of times to get, a file that was like a minute long that I could just play on a loop. Now that we have this repo all set up in order to create the vector sound files based off of the video or image that we give it, we need some video or image to create this oscilloscope art off of. So I just happen to have the video for the intro theme song for the first season Indigo League of the Pokemon animated series. So I'm just going to copy that over from my movies directory here. So now we have it here. And we're going to go ahead and look at the instructions here for the vector version on how to use ffmpeg to extract a bunch of frames. So we're going to go ahead and run this code, but we have to make a couple changes. So first of all, video.mp4, this should be the video itself. FPS, this is the frames per second we want to extract, so we were doing 15, so it knows how many images to create per second of the video. And then it's not really discussed in the README, but best that I can tell, this Y resolution should be filled with the rate to get the correct ratio of the dimensions of your oscilloscope. So I just counted the divisions on my oscilloscope, and on the x-axis there are 10 divisions, and on the y-axis there are 8. So if we have x is 1, then y should be 0.8, and this seems to work pretty well. I think this is what they're going for here. So if we go ahead and run that, it will quickly extract all of these image files that are from that video. So if we go ahead and just open one of them, so let's open like 519. You can see it's just some still from that video. So now we're ready to go ahead and run the vid to oscilloscope, the vector version. And so this is going to go through and frame by frame convert each of the stills into a vector graphic from Potrace, and then it will take that and do some math and figure out how to turn it into the voltages for the sound file and bring them all together. And this will take a little bit of time, so we're not going to sit here and watch the whole thing in normal time, but you might be sitting here for like 20-30 minutes waiting for this all to happen. So the code has finished running. It took about 20 minutes, a little less than 20 minutes to run on my machine. If it's taking too long to run, you can decrease the frames per second, you can change the sample rate. Obviously a longer video will take longer. I assume that the length of time in order to generate the WAV file is directly proportional to the length of the video, so keep that in mind. And it generated this vector OSC output.wav file, which I've just renamed to Pokemon.wav for convenience. There's one other useful piece of information in this README file, which is that they give us a link to this tool right here, which will simulate the XY mode of your oscilloscope. So you can do a good amount of debugging in here. It also lets you do some signal generation. But anyway, we'll just run our file here. So we're going to go in and pick our Pokemon.wav. So first, there's that annoying noise, and that's again because this is not the oscilloscope art where the image that you're seeing corresponds to some sound file that is pleasant and musical. Instead, it's just whatever noise is necessary to create the image on the screen. So I'm going to play it again, and I'm going to mute the sound, and we'll just look, though, to see that the image looks okay. So that looks pretty good. So presumably this file now will work on our oscilloscope because we just simulated it here on this browser application. And so now let's go ahead and actually play it through the oscilloscope and see what we get. So we can see on the oscilloscope that it looks like the file looks pretty good. This looks like a good representation of what the intro theme song to the first season of the Pokemon animated series looked like. Well, thanks so much for watching. I hope that this was informative and that people go out and try this and make some cool images and videos based off of things that are meaningful and important to them or they think is cool and interesting. If you have any questions, please leave them in the comments. I'll try and respond to any questions people have and help people walk through if they run into issues with the code or with getting the sound files generated. And if you have questions that are about the oscilloscope specifically, I can try and answer them, but I'm again going to point you to that YouTube channel where there's a lot more in-depth information on how this oscilloscope music works, what XY mode is, as well as how to set up your oscilloscope properly. So thanks again for watching, everyone, and I'll see you next time.